Such a privilege and an honor to have the chance to begin the day with you here and all of you who are streaming from around the world. Good morning, good afternoon, good evening. And Sarah, you could not have set me up more perfectly in that the metaphor that I want to start with is the journey on a path. And you've explained how it is that all of you are connected on this path, this journey, due to the experience that you've had having children, being surprised by what's befallen you. And I want to emphasize that we all are on a path. And it's really conveyed by the fact that all of us in the room, all of us watching, are connected to the world of epilepsy, whether we're a parent, a patient, a caregiver, a scientist. It all begins with this meeting, this sort of universal get-together of healers and patients. And whether it's a swollen ankle or a lump found in the breast or pain in the abdomen or a child with a first-time seizure, we go seek help from a healer, a physician, a clinician, a professional. And when we do that, and this is true for all of us, we ask what I call the three universal questions that we ask of a healer. And actually, by the way, there are some images that I use here that are all drawings or paintings from people with epilepsy. That's the artwork that I've used for a number of these slides. And those three universal questions are the following. The first is, why did this happen to me? Why did this happen to my child? Right? The second is, can you help me? You wouldn't be going to the doctor or a healer if you didn't have that question. And the third is, what does my future hold? Right? Probably the most important question. And this is what we think of as physicians when we're taking care of patients. And in the world of epilepsy, sadly, we are unable to answer most of these questions most of the time. And boy, do you all know that as well, right? Why did this happen to me? Well, you'll see through the day, and you know this already, that the advances that have been made in epilepsy research have allowed us to answer this question more than ever before. Can you help me? Well, of course, we're going to try and help. But when we think about the reality of what it is that we can do, it causes pause. Do we know which medicine will work? Do we have a medicine that will work? If we choose one, do we know whether there will be side effects? Of the dozen or so, which one should we choose first, or second, or third? So we'll try, but at the moment, we don't necessarily know. And then finally, what does my future hold? The most important question. We actually have very, very little idea for so many of the patients that we take care of. And I want to start this because the path includes this reality that we have to deal with, the reality of today. And to put it into a bit of a historical context, this is a skull, obviously, a human skull, from 500 years ago, and you'll see the large hole in the head. And this depicts what was done for many people with neurological diseases 500 years ago. It's called trephination. And the treatment for almost whatever ails you for a neurological problem was to drill a big hole into the head and let out the bad humors. Yeah. Now, we're looking back 500 years, one would say, what were they possibly thinking about? Right? This doesn't make any sense. And yet, they were doing the best that they could. There were occasional cases that actually this really did work, certain kinds of bleeds in the brain. But they applied it to many, many others who probably didn't need it. So it's easy to look back 500 years ago and be fairly critical of what they were doing. And I've raised this because I think the people 500 years from now, looking back, will also be rather critical. I mean, they'll ask, why was it that doctors were giving patients pills that they put in their mouth, in the patient's mouth, that went into their body and went all over the brain when the seizures that they were trying to treat were only from one discrete part of the brain? No wonder they were having so much problems with side effects, because the medicines bathed the entire brain. And what about the surgery that they did? Well, there are certain forms of surgery where the temporal lobe is the cause, and they actually lopped off 5 centimeters of tissue. What were they thinking of? And finally, why was it that they only began to know or recognize at the end of the 20th century and the beginning of the 21st that epilepsy is not characterized just by the horrible seizures that patients have, but it's all the other things that occur, what we call the comorbidities. And again, I know how well I can see how well you understand this. And they'll be critical about the fact that it took so long for us to recognize that there are many aspects of epilepsy that are far, at least as bad, if not far worse, than the intermittent seizures. Well, characterizing this way is, my sort of internal joke is, that's the low point of my talk, okay? Okay? Everything is now going to go uphill, all right? Because the point here is this path that we're traveling, this difficult odyssey that Sarah so well described, is a path that involves trying to understand how to cope with the reality of every day and the hope that we must have in order to find fulfillment for ourselves, for our children. And so I'd like to take a quick look at what I think is the sort of the future of the care of people with epilepsy. This is a sort of a 50,000-foot view. It's going to be skimming along the surface for the most part, in part because the rest of the day is going to be diving into the remarkable advances that are being made scientifically and that are having an impact on the patients that we serve. And so the care of people with epilepsy in the future is going to involve precision, understanding at multiple levels of very, very complex systems that we're beginning to understand. And I'd like to dissect those apart a little bit with you. So these systems include multiple levels, and I've included just a handful of them. There are many more, but they include things like the genome, which is most familiar to us, but there are other levels that are becoming more and more applicable to the care of every patient, including the transcription of the genome, what we call the microbiome, and others. I'm going to go into some detail with each one of these. And the analogy here should be evident if you think about it as comparing it to Google Earth, right? So when you think about the various levels that you can analyze where we are sitting here at this moment, you can take kind of the global view and know where you are at the map, but it also includes the governmental boundaries, what the weather map is telling you about, what the traffic is occurring at the moment. You can even look at the level of the surface of the Earth, okay? And so it's really quite an analogy to the future of the care of people with illnesses of all kind is to get at a level of precision at multiple levels at an individual basis. And the idea here is that if you have large numbers of people with data at these multiple levels of precision, that you can understand a lot more by looking at the population level, gathering data on large numbers of patients to try to understand what specifically is affecting an individual patient, okay? And that's called the application of the knowledge network. So let's take a look at some of these levels. First, the microbiome. I can't tell you how excited I am about this incredible advance in biology and the way it's being applied to medical sciences. The microbiome is amazing. It essentially is the organisms that exist in or on our body. Our body contains about 2 to 3 trillion cells. At latest estimate is we have at least as many of those foreign invaders, if you will, inside our gut and on our skin. It's called the microbiome. It's essentially another organ in our body. It's just made up of cells that are not us, okay? So it's all these bacteria, for example, in the intestine, and what's truly incredible is only over the last decade or so have we come to realize that the state or the nature of our microbiome absolutely affects the function of our brain. So it's an interaction between the gut bacteria and, for example, circulating molecules in our bloodstream called cytokines, which can be triggered by the makeup of our individual microbiome. And those cytokines actually can cross into the brain and have an effect on growth factors, which affect the way neurons grow, and on activation of the internal immune system in the brain. And we're only beginning to get into this. I won't delve into an amazing paper that came out in June of last year by some colleagues down at UCLA in California, in which they showed that specific bacteria within the gut can actually emulate the ketogenic diet. And maybe we can talk about that a little bit later. So that's one example. That's the microbiome. Let's see, what else do we have? What do we have next? The exposome. So the exposome is defined, as shown here. It's basically what we are exposed to in the external environment. And as you can see from the picture, that includes things like cigarette smoke, the things that we drink and eat, the pills that we take, the viruses in the environment, radiation, and so forth. And we haven't had a very good opportunity to really understand the way exposures to various things in the environment affect humans at the individual level, because we need to be able to understand it at a population level. But that information is beginning to come in, and we're even seeing some early application in the world of epilepsy. Could seizures actually be related to the weather? I had a patient once who came into me, to my clinic, and we were talking about his seizures, and he said, you know, I had these auras, and I said, well, can you tell me a little bit about the auras? He said, well, they're really hard to describe. All I know is, quote, there's seizures in the weather, unquote. I love that description of an aura. Well, it turns out that actually colleagues here in Australia have taken a look at population level data as to whether there's any potential correlation between seizure likelihood and the weather. And this is work, fantastic work that Dean Freestone and Mark Cook and others have done. And this is in a group of patients who had an implantable electrode system, and that they were able to follow the seizures, both clinically obvious ones and the ones that the patient wasn't necessarily aware of, every day, 24/7 for months and months and months. And they just correlated the seizure onset to what the actual ambient weather was. Now, this is just a correlation, it's not a proof, but this is the pattern of seizure likelihood in each individual patient. And you can see there are some people who seem to have their seizures more often when the temperature's high, and others it's in the opposite direction. But it's an example, again, of understanding how the external environment could have an application to an individual patient. Very cool, very cool. Okay, let's see. This is a clinical test. So this one has been evolving, arguably one of the most important advances over the last 3 to 4 decades has been the remarkable improvement in imaging, and everyone should be aware of just what a high-quality MRI is doing in terms of understanding what the brain looks like, being able to identify focal abnormalities and so forth. And I won't belabor it other than to say that this continues to be very fast-moving, and it's going beyond just the anatomical description of what the structure of the brain looks like, but more and more getting a functional idea of what exactly is happening at a metabolic level, at a biochemical level in different parts of the brain. What we're lacking, and that we really need to continue to work on, and I'm hoping that there will be a breakthrough sometime in the coming years, and that is, here's an article related to the cancer field called Cancer Biomarkers, but what we really need is epilepsy biomarkers. And this is going to be a key area of research that, again, people are building on. But one of our major stumbling blocks continues to be we don't have a test that we can use for an individual person which gives us an idea of the level of activity of the epilepsy in the individual. The EEG does it, but it does it imperfectly. And what we're dreaming of is some kind of circulating marker that we can measure so that we can come back to you and say, great news, this drug seems to not only be stopping the seizures, but the underlying epilepsy seems to be getting better, right? And at the moment, we lack that. Let's take a look at genomics. I'm going to leave the least amount of time on this because that's what the rest of the day is. But I have had the very good fortune of being able to work with people like Ingrid Scheffer, Ann Bedori, Steve Petro, Sam Berkovic, who's here in the audience, and many, many other people from around the world in an incredibly collaborative and constructive and supportive way to identify many, many, many people, folks like you, families like you, to be able to bring together the kind of data sets that we need to understand the genetic basis of epilepsy, and along with many other groups around the world, I think most people would say that the most notable advances in all of epilepsy research over the last 20 years has been in genomics. And for those of you, well, this applies to the entire country of Australia, you should be very, very proud that, in fact, history will show that it was the Australian scientists who led the world in terms of epilepsy genetics. No question about it. So you're aware, again, of the types of genetic causes that have been identified in some of you. This is a wonderful paper that Ingrid and her colleagues put out a couple of years ago. Now I still use it because it's just a beautiful example that demonstrates the incredible progress that's been made. You don't need to see the details in this important figure, but you will, if you have a genetic diagnosis, it's almost certainly on this, unless it's been something discovered in the last year or two. But the point here is to just show the phenomenal progress that's been made in being able to identify the genetic basis of the epilepsies. And what's, I think, amazing is that at this point, actually, I'm going to change this slide. It's probably 50%, 50 to 60% of all the epileptic encephalopathies can be now explained. 10 years ago, 5% maybe? What do you think? I'm looking at Ingrid. Yeah.
In 2001, it was Dravet.
Okay, yeah. So incredible progress to be able to say this today. And that, to all of us, should be clear evidence that we truly are at the dawn of what we call precision medicine, where for each individual patient we'll be able to make the diagnosis and begin to identify the therapies. And the implication here is that by having a genetic diagnosis, we can begin to tailor the treatment of particular therapies. And this is a wonderful slide that Ann Padori, I write to her every time I'm getting ready for a talk and say, Ann, do you have any updates on your slide? And I'm not going to go into the detail, but yeah, if you want to take a picture of it, really this does sort of capture the state of the art in terms of treatments that can be tailored to individual genetics. And again, you're going to hear more about this through the day. Steve is going to talk about some of the exciting studies that he and others are doing. But I just want to emphasize that by having a genetic diagnosis, we can now identify the potential target for therapy. And here's just one example of, this is actually a company, originally Paranomics, now Q-State, in which they take the genetic mutation and they model it in the laboratory, and they'll do work like what Steve is doing, and they can actually test drugs. So they have a shelf that has over 1,300 different drugs, and so they just try these FDA available drugs on a particular mutation. And in this particular case, they were able to identify 2 drugs that potentially might be applicable to KCNQ2. But this is being done in multiple labs around the world now. Here's another example of I think, a spectacular breakthrough in basic science that's going to be applicable to our world. And this is work that's come out of the Allen Institute. I just learned about this a couple of months ago. This is pretty darn amazing. So it turns out that our brain is made up of a gazillion neurons, but they come in many, many different subtypes. And I don't think we've appreciated just how many. At last guess, there's probably 200 different subtypes of neurons. And we've been generally treating them as either excitatory or inhibitory. Using a very clever approach with single-cell sequencing, these investigators have been able to pull out sequences from individual neurons, and they've been able to group them into multiple groupings. But most importantly, they've been able to identify a sequence of DNA that we call an enhancer, which allows for up or down regulation of an individual gene in a cell-specific manner. And that's what's so key. By being able to identify these cell-specific enhancers, they've used an adenovirus as a means of a mechanism of getting a particular gene into a particular cell, and they've been able to actually upregulate a specific gene in specific subtypes of cells, not like all excitatory cells or all inhibitory. I think this is a tremendous breakthrough because it's actually what we need. It goes back to what I was saying before. We don't want drugs that go in and bathe the entire brain. We want therapies that go and find the specific subtype of cell that we know is involved in the network-based causing the epilepsy. Okay, let's see. I just have one or two more levels, I think. Real-time, yes, real-time patient-derived data. This just emphasizes how technology and wearables and ingestibles are allowing us to gather information on individual patients. And I'm just going to give you two sort of fun examples. Maybe some of you have already seen this. One of these is called PillCam. This is a little pill that you can take. You put it in your mouth. It goes down into your stomach. And it just basically starts traveling through your intestine. It's sort of like the great, space voyage. And here it is. It's seeing a little polyp. It's kind of a do-yourself colonoscopy. I don't know. It seems more pleasant than the regular one. But this is just an example of how it may become easier and easier to do individual precision-level surveillance of patients. Here's another one, quite cool. This is called Proteus. This is a microchip on a pill. As you'll see, it's about the size of a grain of sand. And so if you package that or put it onto pills, it gives you an opportunity to know about the ingestion of the pill and to keep track of the compliance with the medicine. So here's the patient. There's the little sensor, grain of sand size. It's on a pill. You take it. It goes into your stomach. It's actually metabolized by the acid. So the acid itself gets the little mini battery to work. Then it gets, the signal is sent, I think by Bluetooth, to a patch on your abdomen. And then that, of course, can be sent to your iPhone, and that can be sent to your doctor, and it's a way of being able to keep track of taking medicines. Very cool. Okay, but the most important wearable is the one that's being, again, developed by many companies around the world. Whoever comes out with a socially acceptable, easy-to-apply, highly reliable and valid means of 24/7 readout of brain activity, that's going to be a game changer. There are a number of devices that come out. The one that certainly has changed our world has been the responsive neurostimulation system, the RNS system, by NeuroPace. This is it has to be placed surgically, so it's implanted inside the skull, and it allows one to constantly monitor brain signals. And again, this has changed the world of epilepsy because we're now finally able to monitor the activity of an individual's brain. This is a paper that came out of UCSF. It's one of the reasons I'm highlighting it, because I know the colleagues that did this. It's a beautiful paper that came out in Nature Communications last year. And this is the readout from, I think it was about 34 patients who had this RNS system. And they just looked at the activity of coming out in both men and women, as you can see. And you can already see some interesting patterns, right? This is over time. Each of these is a month. And it's easy to see that there's some patterning overall in groups of patients. Well, if you look at individual patients, here's an example of the readout of the amount of sort of excitability from the individual's brain. And each red dot is where a seizure occurred, so a clinical seizure event. And again, you can probably begin to pick out some patterns here, right? I mean, where are most of the red dots, right? They tend to be on the up phase of a spike in activity. And when they looked at this at higher detail over time, they were able to see a number of different rhythms. Now, we all know about circadian rhythms, right, the 24-hour clock, but they, interestingly, were able to see a number of others. For example, in some patients, there tended to be a 10-day rhythm. And most notably, there was a 26-day rhythm. And that was separate from cycling in women versus men. This was consistently seen in most patients. And so what that allows one to do is to identify this sort of periodicity. And at an individual level, you'll have patients in which there's a readout on different time scales. So it may be that, this is the coming month. At the moment, you're in a good stage, but in about a week, we're going to have to start looking for the potential pattern. Oh, here's a day where you're beginning to have an upswing. The likelihood or the possibility of a seizure is even greater. And what this leads then to is the fact that this idea of being able to have a readout and having an information about the possible risk, as you can see, I think that's going to be sea change. And I bet you everybody agrees with that, right, for sure. Okay, well, I've touched on precision medicine and epilepsy and how I think it's going to be a series of layers. And I just included a number of others because I haven't talked about some of the other levels of precision medicine and ones that we haven't yet even identified. But I wanted to end, or sort of begin to close, with a couple of stories or observations to try to bring us back to this idea of the path. And here's a path, and this is a story. This is two physicians were walking along a path one day. It was their regular Sunday morning walk, their favorite path, next to a river. And they were talking about the previous week, they're good friends, and they suddenly heard this screaming, this hollering. Someone obviously was in trouble, and lo and behold, they looked upriver, and there was someone who was coming around in the current, clearly drowning. So one of the doctors jumped immediately in, swam, pulled the person out, resuscitate them, and they called 911 to save the person's life. So the two doctors continued their walk, and wouldn't you know, a few minutes later, another scream for help, and around the bend comes another person clearly drowning, a little child, and same doctor jumps in and swims out and saves the person, brings them back, saves a life. Most stories come in threes, so they continued their walk. And a few minutes later, another scream for help. It's clearly someone who's drowning. And the doctor is about to leap in and sees her friend running away and says, I don't know if I can do this. I'm so tired. I'm going to need your help. Where are you going? And her friend says, I'm going upriver to find why these people are falling in the first place. Yeah. So the doctor who jumps in each day and, is with you in clinic, they're the salt of the earth. They're dealing with the reality of each and every day with you. And they're doing everything they can to make things as good as possible with what we currently know. The doctor who's running up river, they're our hope, working together to try to find out how we can prevent this in the first place. Another observation about this path, the Odyssey, and how difficult things are. Be prepared for the inevitable storms. Every single person in this room knows what I mean when I say that life is not the fairy tale that we thought we might have. Every single one of us has our own story of suffering, of the unexpected. Whether it's a spouse who is sick, a mother who we've lost, a child who is not going to have the life that we thought, the wedding that we dreamt of, right? We all know that. And how do we deal with that? How do we deal with that reality? We have to be prepared for the inevitable storms. And my advice is to deepen our spiritual roots. Now, I won't try to venture into suggesting that there's a particular spiritual aspect of the path that we're walking, but I do want to briefly share how this has been helpful to me for the losses that I've experienced in life. I happen to believe really deeply in the philosophy of the Buddha. And again, just to make sure, I'm not suggesting that this is the way. I want to honor everyone's perspective, but I'm recommending how important it is to take care of our spiritual roots. I'm really struck by the story of the Buddha because the Buddha was protected by his parents because they didn't want him to see the realities of the world. It was that fairy tale that we're all taught. But there was something that inspired him to go on a journey. He had to get out of the palace. And so he stole away one night with Arjuna and left the palace forever. And he immediately came across hunger, sickness, and death. And he was shocked that this was part of life. But of course, it was the realization that we all know, which is the reality is the world is imperfect. The world's imperfect. Nature is not perfect. It makes mistakes in our DNA. It causes disease. And I don't believe we have any control over that. So for the Buddha, the question was, given that that's the reality of the world, of life, what do you do with that? if you can't change that, what do you do with it? And that was his journey. And what he came to learn and to teach is that it's not a question of how you can push aside the imperfection of the world. It's how is it that it causes suffering? And he would say that part of the suffering is the fact that we are attached to things that can be taken away. That if we have expectations for things as to the way they have to be, then we're setting ourselves up for a life of suffering and disappointment. And so just as one example of how I think a faith can be helpful, if you believe, as I do, that the world is imperfect and bad things can happen, at least one doesn't have to be tormented, and I really mean that, tormented, by the question, why did this have to happen to me? Yeah, there's not much to go with that question. So to try to separate from that, and to also then recognize that being attached is going to be dangerous in terms of the dreams that we'd like to have. And I'd like to finish then, again, by speaking about the journey. This is an image of Mahatma Gandhi during the Great Salt March many, many years ago. And the reason that this image means a lot to me is Gandhi is one of my heroes, and I thought his perspective on life and how to make the world a better place, his perspective on hope for the future, is so embodied by the way he lived his life and the way he walked his path. And I'd like to finish with a quote from Gandhi that Sarah amazingly has called The Path. And it goes as follows. I know the path. It is straight and narrow. It's like the edge of a sword. I rejoice to walk on it. I weep when I slip. God's word is, he or she who strives never perishes. I have implicit faith in that promise. Therefore, though I may make mistakes 1,000 times, I shall not lose faith. And with that, I'd like to say thank you so much. Thank you.
We have time for questions, and we have some people walking around with microphones.
I hope I didn't scare you off. Yes?
What hope do you think? My son does not yet have a genetic diagnosis. He doesn't have a number.
Here, we're going to...
Here we go. Yes, can you stand and say your name, please, and your question, so that our friends on live stream, in addition to everybody in the room, can also hear us. And we should mention that we are delighted to have people joining us from New Zealand and from the United States, perhaps other places as well. And just quickly, if you have questions, we can't take them on live stream. So if you would go on to Facebook and look for GETA, you're going to be able to find us, and you can type in a question that way, or you can reach us via Twitter. So at GETA or on Facebook. But please go ahead and ask your question. Thank you.
Hi, my name is Claire. My son is Eddie. He's 18 years old and he doesn't yet have a genetic diagnosis. He's a patient of Ingrid Sheffer, and I believe his genome is being looked at in Seattle. What hope do you think, given that there's 50 to 60% tracking of these tiny little mutant genes, that he will soon have the same for him?
Well, I don't know about the word soon, but truly, I don't know when it's going to happen. But our ability to be able to decipher the genome is just improving almost literally with every passing month. And we're still at the early stages of being able to understand every one of those 3 billion base pairs in the genome. We're beginning to, the work to date has started with just looking at specific parts of the genome to try to identify things. It's expanded now to what we call the exome. And now we're beginning to do the entire genome because we think that DNA pieces between genes may be important as well. So it's a matter of time, but you will get to the point where he is going to have a complete analysis of the genome. But I can't tell you whether, I mean, it's not going to be within a year or so. Although, again, with every passing month, by doing analysis and reanalysis, we're identifying more and more genes. I should also say that everything that we currently think might be genetic might not be genetic at the level of the genomes. There are other levels of transcription of genes and what we call the proteome that is also going to be relevant. Yeah.
Any other questions from anybody here? Raise your hand. Yes, we have one over here. Dan? Yes, and we'll get a microphone to you. And Jenny, I know who you are, but if you stand up and tell us who you are and your question.
Hi, my name's Jenny. My son is Lucas. He's 4 months old. I have a question about targeted gene therapy. Do you think, and obviously it's a personal concern, do you think that there's a point where you miss the boat for that therapy? So do we have to treat them in utero, or do we have to treat them within the first 2 years of life in order to change their developmental potential? Or do you think that there's still scope to improve their functionality if they're treated at an older age?
Yeah, I think it's going to depend on the individual gene mutation and where it occurs in development. The ideal, I think, for many patients is going to be the earlier the better. Thankfully, there's a lot of plasticity in the brain early in life. I think once one gets into later childhood and teenage years, the ability for that plasticity becomes more and more limited. So yes, early treatment is going to be key, I think, in many of these syndromes. Yeah. Mm-hmm. Yeah.
Any other questions? While we're looking around the room, I had one for you. I try to keep up in this space, and I was looking at your slides and frantically taking pictures because as much as I try, there's so much more. For our highly motivated, super smart parents who are here today, what would you suggest is the best place to get, if you will, parent-friendly information, the best stuff that we can find out so that we can continue to educate ourselves?
Well, I think the Epilepsy Foundation in the United States has done a very good job of trying to, provide information that's very relevant. This began, I think, with Bob Fisher more than 10 years ago, really thinking about family-oriented information. I think CURE does a good job, Citizens United for Research in Epilepsy. Anne, I'm looking at you.
We've been tasked with communities and tabs with updating epilepsy.com.
So epilepsy.com is
yeah.
going to have more. That's great to know.
Yep.
Ingrid?
International League Against Epilepsy, epilepsydiagnosis.org, that's a major.
Okay, we're going to say that one again.
Yeah, thanks
you.
Ingrid.
The epilepsydiagnosis.org, which is the International League Against Epilepsy website for seizure types. You can watch videos, you just have to register, takes 1 minute, and all syndromology and things, and that's building on the genetics as well.
Perfect.
Yep, good.
And any other questions, just while we've got Dan, and then we're going to move on to our, oh yes, we have one at the back. We'll get to you.
Hi, my name's Kerry. I've got a son who's 10, Tommy, SCN1A mutation, has been seen by beautiful Ingrid. I liked your comment this morning with we sort of know the drug therapies aren't the answer, and it's a question every parent has, and I guess if anyone's got an older child can see decline with both the seizures unfolding in the medicine. How far away are we with those possibly genome treatments or any other kind of treatment where we're just treating the actual coding problem? Is there a time frame or anywhere closer to starting those sort of treatments?
It's such a hard question to answer. I'm truly incredibly optimistic that time is coming closer because there's so much activity going on in this space. At UCSF, where I work, the number of gene therapies that we're working on related to cancer is incredible. And actually, in the world of oncology and immunotherapy, breakthroughs are happening, at an incredible pace. And fortunately, I think that's going to help us in our application to the brain. The problem that we face, though, is the brain is the most complex entity in the known universe. And it's not going to be as simple, and I put simple in quotes, as the approach to treating cancer. But for certain know that the amount of effort that's going into this, you know, gene therapy at a individual level is enormous. Yeah.
All right, we probably have time for one more question, and then we'll wrap up to keep us on time. Yes? Who have we got? Anyone else? Yes, right here. You get to be the lucky last. We'll wait and get you a microphone.
That was a fantastic talk. I really enjoyed it. Thank you. I'm Carolyn. I'm from Adelaide. I'm a GP and a mother of Liam, who's now 16. We had to bring him across to see the amazing Ingrid. It was like, our journey was like, we were looking for the Wizard of Oz, and we found her. But she actually was everything that we expected. My question is, we have neurologists who are not on this journey with us, and we're just trying our hardest. And us parents from Adelaide know a lot more about genetic epilepsies than our neurologists do. How do we take them on this journey? I'm just looking for some of your wisdom, which I really enjoyed.
Oh, it's such a deep question. It's interesting you mention that, because last night we had dinner with a number of folks in the room, and that theme came up a couple of times. You know, as a non-Australian, I can't fully appreciate the dynamics that take place in terms of the healthcare system, but I heard a story very similar to what you said. We just need to keep working at the way we train our health professionals, for them to understand that all of us need to understand the perspective of the patient, and to be humble, to be compassionate, to be very willing to enable our patients to go get advice from others, and see that as an opportunity rather than an offense. Everyone deserves to have a doctor like Ingrid Sheffer. Yeah.
Yes.
So that's a good place to stop.
And Dan Lowenstein.
Yeah.
Thank you.